Okay, as written, this really is not a L'Hopital rule problem, and the reason that, as x goes towards 0, the first limit doesn't even exist, all right? The second limit also doesn't exist. So what I'm gonna do is I'm gonna just, kind of massage a little bit and write this a little bit differently to see if I get into quotient. And again, I'm looking for two different things. I'm either looking for this or some kind of, infinite growth on bottom and top. Doesn't matter plus or minus though. So let's take a look at this. X goes to 0. And then you can get x times the arctangent. And on top, what do you get? You get arctangent. Well, what's nice about this is the limit of the top is, I'm sorry, I made a mistake there. The limit of the top is 0, and the limit of the bottom is 0. So I'm at L'Hopital's rule now. Let's write this down. I'll put my h over here, limit, and let's hope things go as advertised. What do you get on top? The derivative of arctangent is 1 over 1 plus x squared. The derivative of x is just simply 1. Let's go to the bottom. It's a product rule. So I got, let's see, x times the derivative of arctangent, which is 1 over 1 plus x squared. Well, let's see, then it's going to be plus, let's see, the derivative of x, which is 1, times the arctangent. Well, you know what, I'm going to simplify a little bit, and the reason for that, let me see, because the top is 0. I don't want to use L'Hopital's rule again, by the way. I might have to. And the bottom is 0. And I'm going to clear the fraction. The limit, x goes to 0. And what would you get? Multiply top and bottom by 1 plus x squared. It looks kind of nightmarish, doesn't it? So you can get 1 minus 1 plus x squared. On bottom, you can get x plus 1 plus x squared times the arctangent. Yeah, it kind of looks nightmarish, doesn't it? I'm going to keep massaging it, by the way, because I don't want to do too much work. And some people may argue, oh, you're doing way too much work. It's minus x squared. And on bottom, you're going to get x plus, I'm going to expand it, arctan plus x squared, arctan. That's going to be tough jamming that in there. I think it's different notation, by the way. Tan with that minus 1, which means arctangent. By the way, I'm looking at it again. I'm still getting the same, loop. I'm getting 0, and the bottom is still 0. L'Hopital's rule again. Let's see, minus 2x, right? 1 plus 1 over 1 plus x squared. And then I'm going to get x squared over 1 plus x squared plus 2x arctangent. And again, I'm going to use that negative, which I don't like, but I'll do it because I can't jam it in there. I think I can do the limit now. The limit of the top is 0. That's not a problem for me. But the limit of the bottom just turns out to be a 1. And the reason being is, let's see, I'm sorry, I shouldn't say 1. The limit of the top is 0. That's easy. This would be 1. If x goes to, that's 1. What would this be over here? If x goes towards 0, this would be 0. And this would be 0. So we left off with, let's write this down. It's going to be equal 0 over 2, which is 0. And we're done. Thank you.